Guys, in today's video, I'm going to take you through step by step how I made this beautiful handmade aluminium coffin tank. I'm going to show you the tank that I've designed. Oh, he's scared of your camera. What's this? Oh. Oh, hey guys, didn't see that. Welcome to Hustler Minibikes, guys. This is the second video. Here we are today in the workshop. Unreal. Can't wait to bring you today's experience. We're going to be making a custom coffin fuel tank. I've developed it all in CAD there. We're going to go through and take a look at that soon. This is the first Vtwin mini bike I've done for Jimmy John's. It's the V200, custom made for Hustler by Odds and Ends Engineering. This custom bike, all scratch built. I made this frame up this week. Been working on a custom Springer seat pan for it. Trying to go for a custom bobber style. You know, this is a really classic bike, something I've always wanted to do. I've found this really nice old school cookie cutter style tyre. It's nice and tall. Really like the proportions of this bike. I'm really excited to see this tank on here, see this bike start to take shape. So let's go check out the CAD files. Hey guys, I'm here at my desk and I've got SolidWorks open. I've designed this faceted coffin tank. It's a sheet metal development and it's quite complex, so I'm quite excited to show you guys something a bit off the cuff here. It's, you know, a design that I'm developing and I don't really know how it's going to look until I actually make it and get it on the bike. I thought about 3D printing something like this from plastic, but the reality is I don't think it's that finesse of a design. I think I've nailed it. I took some basic measurements on the bike and using my ichrometer and that, I think I've come up with something that I'm pretty happy with. I'll give you a quick rundown of how I've actually drawn this in SolidWorks. If I show you the original blocky feature that I drew, it was just like a faceted solid shape, and I've broken it down into 4 components which will plasma cut and then fold in my V-block in the hydraulic press. So the top piece, I've used the top face as the base and then 2 bends, converted that to sheet metal, 2mm thick, and that's our top piece. And then we have our bottom piece. And bearing in mind, guys, I'm folding this in a V-block in a press, so I've got fairly limited parameters that I can work with. So I've tried to keep the bending simple, hence why I've just got the 2 sets on that. And then we're doing the end pieces separately, because I don't have short V-blocks and knives to be able to get in and do the last 2. So again, that one started with the block feature, and I picked the base as the flat plate, and then I've picked the bends that I wanted to use and converted that to the same 2mm sheet material, and I'll show you what that looks like flat. So that's the flat pattern that we'd use for plasma cutting. Basically I can export that by right clicking, exporting it as a DXF, and then with that DXF file we can import it into SheetCam, and I'll create the cam file which my plasma cutter can use to cut the material. So if we open a new job, new part, and there's the coffin tank front piece. So that's the outline, and we cut the plasma. I've already set the parameters up to suit my plasma cutter. There's our cut path, including the hole. And we can see all the order of operations, and we're going to go ahead and just export that G-code, put it under the NC programs on my USB stick, save, and we're done. So that file's on my USB stick ready to bring over and put into the plasma cutter. Okay guys, we've got the files on the USB stick. We're going to head on in and plug them into the plasma table. Okay guys, this is my ArcDroid CNC plasma cutter. I'm running a Strata plasma on this machine. It's a single phase, and we've gone ahead and installed a nice big 32 amp single phase plug for this. We are pulling 30 amps from this, which is quite a lot for a single phase. I've got my files on the USB stick. We're going to go ahead and upload them. I'll show you guys what that looks like, and then we'll get our sheet of 2mm aluminium and we'll start cutting. We've got the plasma cutter turned on, and before we do anything we have to home the arc droids. You'll see it go through its little cycle, bumps into its limit switches. That's how it finds its home every time. Once it's homed, we can actually use the machine. So what I'll do is chuck my USB drive in here, and we're going to go ahead and we'll load the first part that we want to cut. Start with the coffin tank top piece. So you can see the file come up. We can zoom in and out on here. Basically where the torch is that little green circle on the screen. So you'll see it move around as I move the torch around. There it is. So the little green dot is the torch head moving around the table. So we can position the torch head in the center where we want it and then zero the file. That gives us our cut position on the sheet. Right, oh, here's our sheet of 2mm aluminium. I've ordered this. I buy pieces cut about this size because I can manage them easily in the workshop. Obviously my table's pretty small. It's a 600 by 400, so no point having a full sheet and trying to manage that. This here, 5005 grade, so that's a nice formability. We're going to be doing bending on this. Obviously we want to resist stress cracking in the bends, so this is our best option. Well, easily available option anyway in New Zealand. So we're going to figure out how we're going to support this. Basically I'm going to sit it on here like that. So guys, so I've got my pattern all loaded up, I've got the machine zeroed, and I've got the leveling done. Now I can go ahead and start cutting. So yeah, brace yourself. I've got my tinted glasses. Hope Pat's going to be alright behind the camera. Let's make some noise, make some sparks. I'm running 1200mm per minute feed rate. I think it went pretty good. The sheet did distort a little bit as it was cutting from the heat. I might need to just pin it down a bit better. I can see the torch dragging a little bit around here, which can sometimes, you can see the scratch marks, so it was too close, and that can kind of make it get out of sync a little bit. The actual dimensions of this might be a little bit out, so I'll give it a quick measure up and we'll check. Alright guys, so this is the top panel. That's going to get 2 folds in it, and that's going to make up the top of the tank. Let's go ahead and cut the rest of them. So I'm just using these weights to hold the sheet down, keep it flat, because I could see it was distorting and warping as the torch moved around from the heat. It heats up extremely quickly and really localized, but it does have a big effect. Aluminium's not so bad, but stainless steel can be even worse. Okay guys, I've got the bottom piece loaded up on the machine. I've got it all zeroed where I want it. As you can see, we're working just inside the parameters of the machine. That curve there is the arc droid itself, and the white line is the outer parameters that it can cut to. So I'm going to go ahead and push play. It's pretty cool guys. Got a much better result this time by moving the torch cut height up a little. Didn't get any dragging. Nice clean result. Very few flaws. Hey guys, I'm just going to go ahead and trim the waste off this sheet, ready to cut the next few parts on it. Okay guys, here's the parts that I've just taken off the plasma table. I'm pretty happy with all of these. I'm going to go ahead, clean them all up, take all this dross off, then we're going to clean them up with the orbital sander. Then we'll move on and we'll take it over to the press, and we're going to try and press all these, get it all into shape, and then we'll look at welding this bad boy up with the TIG welder. looking pretty good. I've just got these all deburred and fully cleaned up. I just gave them a lick with some 120 grit, which is pretty coarse. It's just to rip off all the residual dross. If I was to make these in a production level, I'd get these laser cut and there'd be a much cleaner surface. The cut would be really square and have no dross, and it wouldn't actually need cleaning up. It would just be straight into folding. So I've got these to the point now where I'm happy enough to start marking them out, and we'll look at folding them up. Guys, I produced some drawings to help me out here in the workshop. They've got all the fold details on them. So there's an overview of what the tank will look like. It's actually 4 pieces. You can see them laid out on the bench here. I've got a separate drawing for each one, detailing the fold position and also the angle at which to bend them to. These are the drawings that I'll use in the future if I want to have these produced for me by a laser cutter with a CNC press brake. Everything's ready to go. This is how I like to work. I like to be future-proofing. I like to think that if a customer wanted one of these again in the future, I can just go boom and push play, copy paste, everything's already done, all the hard work. Okay guys, I've got everything marked out with a fine point Sharpie. Now we can move over to the press and look to start pressing. Guys, I'm going to use a little adjustable protractor to help me measure my angles as I'm bending. Very simple little unit. Okay guys, I've got a multi-sided V-block here that allows me to fold different material thicknesses with the same top knife. I'm going to use this one here for this first part. This is quite a primitive setup. I actually made that myself from a piece of flat bar with a 90-degree edge ground on it. So I want to be taking this one slightly past 90 degrees. I'm not sure if I can actually achieve that in here, so we'll see how we go. It is slightly past. The bend looks good. Again, that's the 5005 grade alloy. It does bend really nicely. Let's see, we need to go a bit more. I'm not going to be able to achieve that in here, I don't think. Very close. That'll do it for now. I'll be able to finish that off by hand. That's that piece done. Grab the next one, which is the same bend again.
Sweet. What do you have there? It's finished.
That's the base of the coffin tank. I'm fairly happy with it. One of these gaps has come out a little bigger than I had hoped, but hopefully we can tweak that a bit. Once I get the top piece done, we'll see how we can bring that together. It's pretty cool. You can see it's really starting to take shape. Alright guys, so the final piece to do is the top. It's a little bit bigger than the other pieces. It's too long for this, so I'm going to go ahead and put this bigger press brake attachment into the press. I'm going to use that. Okay guys, let's start this press up. Just check that angle. Alright guys, I'm just taking care of these 2 top bends. I've got that one done, this one just needs a little more. Alright guys, I've just finished the top piece. I can see this thing's going to come together really well. How cool is that? Check it out on the bike. Yep, that's pretty aggressive. Alright guys, I'm just going to show you the componentry that I'm going to weld into this. I'm going to use this fuel tap on the bottom. So I've machined this little threaded adapter. That'll weld into the bottom of the tank. See the little internal gauze. And on top of the tank for the filler will be this billet weld-on cap. So I'm going to go ahead and bore a hole in here now. I would have bored the hole earlier, except it would have distorted when it was bent. So I'm going to do that in the milling machine with a hole saw. Okay guys, I'm just marking out where I'm going to fit the drain bung and also the filler neck. So I've given a little center punch mark where I'm going to drill that. And the filler bung I'm going to put in there. I'm going to use this 32mm hole saw. I'm going to bore that through the top. Then we're going to machine the base of this filler neck to spigot into it. Then I'm going to try and weld it on the inside. The reason I'm going to weld it on the inside is to avoid distortion. If I put a fillet weld on the top, it's going to try and pucker the top of the tank up. So hopefully this will help. Alright guys, so machine that, so it's a nice tight fit hopefully. Oh yeah. Everything's prepped. I've got my filler neck spigoted on there, ready to weld on the back side. And then we're going to start tacking this thing together, so let's get into it. What is this?
What is that?
You'll see when it starts up. Personalised Kempe welder. Guys, we'll just set the gas flow rate to 11, start the gas test up, come around the back here and we'll see the ball valve currently sitting on 5. We're going to turn it up to 11. We're going to use 2.4mm welding rods. Okay guys, I've got that filler neck welded on the inside, and I've done my best to just make sure I didn't penetrate through the 2mm sheet, because I didn't want any visible penetration on the face that we see. I've done pretty well, and there is a fair bit of distortion though. 2mm sheet is quite thin, so it does move as you're welding. I'm pretty happy with that though, and after it's powder coated, it's definitely going to look really good. So I'm happy with this. I'm going to go ahead and start tacking the whole thing together before I then finish welding. Really good actually. I'm happy with that, so going together pretty well. Sorry.
How's it going there?
Oh.
How's it going?
Oh, pretty good actually. I've got most of it tacked together, and I'm just looking at the front and back pieces now. It's going together really well actually, and I'm quite surprised, you know, what we were able to achieve with that plasma table and some simple V-block press tools. You know, this thing's going to look pretty awesome, I reckon. Alright guys, I've got most of it welded up. I'm pretty happy with how it's going. There was definitely a few big gaps that I had to fill, which were a little bit challenging. Being 2mm thick alloy, it is pretty thin. I've done my best and I'm pretty happy. Bearing in mind, most of these welds will be dressed off and the whole thing will be smoothed up, ready for powder coat. Alright guys, I'm going to go ahead and weld that drain bung on. That's where the fuel tap will screw into. Alright guys, that's it. I've finished all the welding. I've got the drain bung welded on. I'm going to let it cool down and then we're going to go ahead and dress the whole thing. Okay guys, check that out. That is fully welded, it's cooled down. I'm really happy. I think for my first go at a coffin tank, it's pretty sick. I really like the size. It's about 3.3 litres by the way, which is a nice big size. Right now I'm going to use an angle grinder with a flap disc. I'm going to take off the bulk of the weld material, and then I'm going to go ahead and grab my Metabo orbital sander, and I'm going to work my way down through a couple of grits, probably use 120 and then 240, and get this thing down to a really nice smooth finish all over. Guys, I'm all finished, check it out. I've been over the whole thing with 120 grit on the orbital. I'm so happy with this, I think it looks absolutely sick. Let's get in there and check it on the bike, I reckon.
Yeah, let's go in.
Look at that guys, that is sick. That is one seriously cool looking tank. I've never made one of these before. I'm pretty stoked. I think I'll probably be making more. There's lots of things I'd like to try, different shapes, different styles. I'll probably be mounting this with rubber, by the way. I'll be putting some pads on here with rubber in between them, and then we'll bolt it on. You know, take the vibration out. I don't want to risk these brackets cracking, so I'll do my best there. Yeah, I'll give you an idea actually with that seat pan there. Give you a bit of an idea of the aesthetic of the bike. So, pretty cool little custom bobber style. Stoked. What more can I say? There it is guys. You could build that yourself at home. You don't need the fancy gear. You don't need the plasma table. You could be cutting that with a cut-off disc. You could cut that with a hacksaw if you wanted to. borrow your buddy's welder. Guys, you could be making this tank for your full-size Harley bobber if you wanted. This isn't limited to mini bikes. This is full-size bike stuff now. Right guys, in last week's video you saw us assemble this insane supercharged rotary mini bike. Today we're going to take it out for a test spin. We're going to see if this thing does what we say it can do. We're going to take it out, we're going to see what we can hit, we're going to see how many pounds of boost we're running. We're only going to do about 50 kilometers an hour because we're on the road, that's the speed limit. We're not looking to break any rules here. Well, we are, but we aren't. We're on a closed road, by the way, in Mexico. Guys, this thing is insanely fast. I was doing about 50k an hour. It's hardly even trying. Like, this thing will easily do 100, but man, you need a smooth road. It's really bumpy. You can see this thing is absolutely really hot now. I don't want to get it any hotter. You can see the intake manifold. It's forming condensation on it. It's getting so cold from the Venturi effect there. So guys, thanks so much for watching today. I'm absolutely stoked to have brought this to you. Can't wait to bring you more projects in the future, so stay tuned.